Hello, my name is Inigo and I'll be presenting a work titled Attribute Control Translation with Preference Optimization, which has been carried out as part of a research collaboration between the University of Technology Sydney and Amazon Prime Video. Attribute Control Translation, or ACT for short, is the integration of conventional machine translation and text style transfer, where the model not only needs to faithfully translate the source sentence, but the predicted text is constrained to comply with certain predefined linguistic and stylistic attributes. In this paper, we have focused in two of those attributes, gender and formality. In the example on the left, the gender of Taylor is ambiguous, and when translated into Spanish, the model can be controlled to generate the feminine or masculine variant, which only differ by the words highlighted in the text. Similarly, in the example on the right, we observe a Spanish sentence that can be translated into English in the formal or informal style. Previous work has attempted to tackle this problem. Traditional nlPUG models have been fine-tuned with additional control signals, which can be additional tokens or learned embeddings to steer and control the model to translate with the desired attributes. Later, with the advent of multilingual LLMs, other work has shown that prompting techniques can be also applied somewhat successfully without the need for fine-tuning. However, LLMs can also be fine-tuned, and preference-based alignment has become one of the most common approaches for it, with algorithms such as direct preference optimization. Our hypothesis is that ACT fits naturally in this training framework, as we usually have contrastive samples with opposing attributes: formal, informal, masculine, feminine. For example, if the target is formal, this will be the preferred reference, and the informal will be the rejected preference, and vice versa. However, in our early experiments, we have observed that the straightforward use of contrastive samples from typical ACT datasets significantly compromise translation quality. As shown before, training references often only differ in a couple of tokens, but their overall translation quality is comparable. The model learns to overuse those tokens, but not what faithful translation is. To address this issue, we propose to generate synthetic preference pairs that align better with the dual nature of the task, which is simultaneous attribute compliance and translation. For that, we rely on two existing metrics: EMAC to measure the attribute compliance of the generated samples, and EACL as the reference-free metric for translation quality. We use source sentences from the available training data, and we augment it with synthetic samples with the following algorithm. So we start with a source sentence, in this case a Spanish sentence sample from the training data. This sentence has also a formal and informal translation variants in English, which are available as references in the training data. But our target in this case is a formal translation. So first we use an LLM, in this case Sonnet 3, to sample K formal translation variants. Then we check whether the translation matches the target formality with EMAC. Then we measure the translation quality of the valid sentences with EACL, and we select the best one. This sentence will become the new preferred candidate for translation, and the informal reference in the dataset will become the rejected sentence in the translation. So this way, the generated preferences have a clear difference both in translation quality and the attribute that they are targeting. We have applied this approach to two existing datasets, COCO-MT and MT-Geneval, which are one for formality control translation and the other one for gender. And they're both English as the source sentence and translate to various target languages. We have also generated a much larger formality control translation dataset called PreFame-MT. This dataset has been generated extending an existing dataset called FameMT, and we'll show you how. So basically, FameMT is a formality annotated translation dataset, but without contrastive target examples. So what we've done is to use another LLM to generate the translation with the opposing formality. In this case, if FameMT had a sentence with a formal translation, we use an LLM to generate an informal version of that translation. This way we can use it for preference optimization. We have identified the longest common subsequences to annotate the key different token spans, and to generate a good quality test set, we ask professional translators to assess the quality of the contrastive examples. Training and validation datasets have not been evaluated by human annotators instead. The result is a much larger contrastive ACT dataset for formality, if we compare it to other datasets like COCO-MT. Additionally, we have observed that our dataset has a higher lexical diversity in formality expressions, while CocoaMT mainly expresses formality through the use of personal pronouns. We trained 3 different models. nlV, a small encoder-decoder model pre-trained to translate between more than 200 languages, and then QM3 8 billion and Euro LLM 9 billion, 2 multilingual LLMs. Models are trained using contrastive preference optimization, a memory-efficient variant of DPO. And as baselines, we compare it to an instruction-tuned model, which uses only the preferred references, and CPO baseline, that does not use the synthetic data. We also compare our approach to zero-shot and few-shot in-context learning of Claude 3 Sonnet. For evaluation metrics, we have used 2 groups of metrics, some to measure the attribute compliance of the predictions, and some to measure the translation quality of the predictions. More details of each metric can be found in the paper. So first we show the main table of results in the CocoaMT and MTGeneval datasets. We want to highlight that with the NLV model, CPO fine-tuning has substantially improved attribute accuracy in both datasets, but with a drop in performance in translation quality. Instead, we show that when we use CPO with the synthetic data, the model obtains more balanced improvements across all metrics. QM3 sees a smaller but consistent improvements in all metrics, but clearly the improvement is larger when we use the proposed synthetic data with preference optimization, obtaining statistically significantly improvements. When comparing to large NLMs, we see that even the small NLV model can sometimes outperform models such as Claude, Sonnet, or RAMP when attribute matching. In the paper, we showed that these results extend to non-English language pairs. In CocoaMT, we have aligned the available non-English targets, and we have run experiments with 71 distinct language pairs in total. We see that the trend is same in all of them. The model trained with the synthetic data aligns better to both improve attribute compliance and translation quality simultaneously. Finally, we have results over our new proposed dataset. Overall, the absolute attribute compliance scores are much lower. This could be because the dataset higher lexical diversity, instead of only using pronouns to highlight formality. We observe that the same trends in our NLV model. CPO improves attribute compliance, but at the expense in translation quality, and using synthetic data obtains more balanced improvements. QM3 and EuroLLM obtain modest but noticeable improvements in all metrics too. Here we show a qualitative example to understand the kind of improvements the model learns to make with the synthetic data. We see that the zero-shot NLV model, which is uncontrolled, doesn't use the correct formality pronoun. It uses usted instead. In Spanish, that means it's a formal pronoun. The instruction-tuned model and CPO baselines manage to learn how to use the correct informal pronoun, but only the model that uses the synthetic data knows that the proper name Rotten Tomatoes should be kept and translated, obtaining a much higher QE score. We have also carried out a sensitivity analysis of the amount of synthetic data that can be used for training. Generally, we see that using more synthetic data is better for all metrics. This means that we have not reached a ceiling, and budget permitting, more synthetic data could be sampled for more training. So, in conclusion, we are the first work to investigate the use of preference optimization in ACT. For that, we have proposed to use a synthetic data generation strategy that balances the improvements on attribute control and translation quality. We have also proposed a new ACT dataset for formality, PREFAME-MT, which is lexically richer and much larger than other existing datasets. And we have proposed also new evaluation metrics for attribute compliance measurement, which the details can be found in the paper. Finally, our extensive experimental results demonstrate that effectiveness of the approach in various languages and datasets. So this is all our work. For more details, please check the paper. All the data and code is publicly available, and don't hesitate to reach out if you have any questions. Thank you.